transformation of graphs, functions, which matrices. Okay, so as I introduced at the very beginning, giving you matrix is the same as giving you word description. Okay, giving you matrix is the same as giving you the word description. So let's say we have a transformation is defined by this matrix. Okay, you probably can tell me what has been applied to this matrix. It's a dilation of vector 2 by the x-axis. Okay, you should be able to see this. And then find the equation of the image of the graph of the quadratic equation under this transformation. So there's a particular way of how we can write this. Okay, there's a particular way of how we can write this. We'll write T bracket matrix xy. This means the image of this matrix. Okay, it's the image of the x and y. So this xy under the transformation. And that equals to what has been applied times the old coordinates. So what you have is x dash and y dash. That will equals to what? Okay, row and the column will have x to y. Okay, x and to y. So x dash equals to x and y dash equals to 2y. Because you have the original equation, you're trying to find x dash and y dash. So you need to make xy to be the subject in terms of x dash and y dash to substitute to obtain the function x dash and y dash. Therefore, we can make y equals to a half y dash. And let's put things in. Y just a half y dash equals to x dash squared because x equals to x dash plus 2x dash plus 3. So y dash will equals to 2x dash squared plus 4x dash plus 6. So y equals to 2x squared plus 4x plus 6. This is an easy question. Okay, this is an easy question, but I just want to show you the idea how we can set up the equation, how we can write those things. Okay, so T bracket matrix x y in row 2 column 1, that means x dash y dash. Okay, that's a notation. It means x dash and y dash. It means x y under the transformation T. Okay, example 2. Example 2, a transformation is described by the equation T bracket x plus b bracket equals x dash. Okay, that's another notation. You just substitute the things you need. Okay, substitute the things you need. What is x dash? X dash refers to x dash y dash. Okay, in the row 2 column 1 form. That equals what? Equals to t. What is t? T is 0, negative 3, 2, 0. Bracket. X plus b. What is x? The capital X represent xy. Okay, the capital X represent xy. Plus b. What is b? b is 1, 2. And finish the bracket. So what you need to do now is just calculate. You have x plus 1, which is one number, and y plus 2, which is another number. And we have row, and that's a whole column. You have x dash and y dash equals to 0 times that becomes 0. And negative 3 times that is negative 3 y plus 2 in the bracket. Okay, in the bracket. And 2 times x plus 1 bracket, they are in the bracket. So what x dash equals to? X dash equals to that. And y dash equals to that. There's a reflection in the line y equals to x, if you can see that. Okay, there's a reflection in the line of y equals to x. It's the inverse function. And And I have the original equation. Okay, I have the original equation, so I can't use original equation. So what I will use is y. Okay, y equals to negative a third x dash minus 2. And this one gives you x equals to a half y dash subtract 1. Then I'll put things in. 2x in the bracket and plus 5. Let's just get rid of the x dash y dash. It's a little bit annoying. Minus 2 plus 5. Minus 2 plus 5 is a plus 3. So y will equal to, move the 3 to the other side, is negative a third x minus 5. Negative a third x minus 5. Any questions so far? We'll do a really complex question in the end. Okay, we'll do a complex question for matrix in the end. Okay. Okay. Anyone can tell me, is that looks familiar to you, this question? Anyone can remember that? Maybe it's not exam. I think it's one topic test. Yeah. How many of you make mistake on this question? Yeah. A lot of students got this question wrong. And I'll tell you why you get this question wrong. Because like, I think most of you will find the correct answer. Like, you will know, okay, that's a correct transformation. But in the end, what happened is, I can't find the correct answer in these options. Okay, I can't find the correct option in this one. Where's the problem occur? Is the reflection. If it's a hyperbola graph, it can be reflected in the x or can be reflected in y. It depends on where you put this negative. Okay, where you put this negative. That's the problem. So what we can do to this one? Okay, what we can do to this one? So I will still do the same thing. Y will equals to 1 on x and y dash. Okay, that's the new graph. So y dash. So y dash minus 4 will equals to minus 2 over x minus 3. I can't have this minus 2 here, so I will divide it to the other side. So divide by negative 2, and it's 1 over x dash minus 3. And this equation looks good now, because it's 1 on something and 1 on something. So the model is 1 on something. So the next thing I will do is equalize both sides. So negative 2y plus 4 equals to y dash. And I will equalize x equals to x dash minus 3. So x dash equals to x plus 3. Minus 2y plus 4, okay? Okay, so how we can set up this equation? So x dash y dash should be equals to x has no change, that's 0 and 0, and we have negative 2. And for xy. And we think about the movement, which is 3 and 4. And surprisingly, you find that, okay, we don't have that thing, okay? We don't have same thing in the options. Okay, that's most of you wants to point out. But like, that's definitely a correct answer. Okay, there's nothing wrong with this answer itself. It's just we can't find the option in the multiple choice. Okay, so if you can't find that, you may question yourself. Okay, D and E really look similar. Okay, looks similar to my answer. What happened? I put this negative to the other side instead of putting down. Okay, so what I may change here is, Okay, I'll change this equation here. How I can change this one? Okay, I'll change this one. Let's put the thing here. I will put that y dash minus 4 over 2 equals to 1 over minus bracket x dash minus 3. Instead of putting the negative to that side, I'll put the negative down, okay, below 1. So what I will have now, I will have y equals to y dash minus 4 over 2. So y dash equals to 2y plus 4. X will equals to minus x dash subtract 3. Then x dash will equals to minus x plus 3. Now I can rewrite this. The new point equals to, okay, negative 1, 0, 0, and 2. Negative 1, negative 1, 0, 0, and 2. And I have xy, and plus 3 and 4. And I can find that's my option E. Okay, that's the option E. Do not try to expand every single transformations and try to substitute and try to see whether I will have the same equation in the end. That's just 2 waste of time. Okay, 2 waste of time. If not necessary, do not try to work from the options to the answers. Okay, try to think about a way like I can do it. If I find there's some problem, how I can overcome that problem, what I can do. So same thing happen here. If you find your dilation factor is different, or if you find your reflection is in a different place, that's you will start to think about, okay, should I change some format of this equation, and I can find out the answer. Okay, example 4. The matrix which determines the transformation dilation from the x-axis of a factor 2, followed by a dilation from the y-axis of factor 3 is. Okay, I make this question here is I want to tell you if you cannot write the matrix at once, you need to times the matrix in the front. So what that means, if you have T bracket xy, okay, that will equals to xy, which is the odd points. Okay, what's the first transformation? The first transformation is, okay, the first transformation is the dilation from x-axis of factor 2. So it's changing the y value. So that's 1, 0, 0, 2. Okay, that's the first matrix what's happened. 1, 0, 0, 2. Followed by a dilation from the y-axis of factor 3. So 3, 0, 0, 1. You need to times the followed by in the front. Okay, you times the one you have later into the front when you times it. Okay, the order will be important for some case. Okay, maybe not for this case, but it will be important for some case. So remember, always times your matrix in the front. Okay, not at the back. Okay, not at the back. Try to times it in the front. So what I will have here is so that's a 3, that's a 0, 0, 2, x and y. Okay, so the matrix will be this. This will be the matrix, 3, 0, 0, 2. Okay, so that's most things we can do for matrix. Okay, that's most of the things we can do for matrix. I will have a big question later, but I want to go through some of the using transformation to sketch graphs. How many graphs we have? First of all, can you write down that's your homework for today? That's your homework for today. The challenging questions. Okay, try to do that. If you have seen that before, try to do that by yourself again. Do not go back to your answers. Okay, try to do the entire question. That will give you a better understanding on matrix. Okay, that will be a better understanding on the matrix. And let's do the last exercise, which is a little bit new. Okay, a little bit new. So first one is like they give you a graph and ask you to sketch the graph. So for example, the first one, I know gx equals to fx minus 2. So that is moving to the right by 2 units because x equals to x dash minus 2, x dash will equals to x plus 2. So it's moving the graph by 2 units to the right. So I will find some points on the graph. For example, this 2, 0. And then I will have 1, 1 will move to 3, 1, which is here. Okay, 4, 2 will be moved to 6, 2. Okay, so the graph will look like this. Okay, some shape like that. And you need to label a couple of points. That's 2, 0. That's 3, 1. That's 6, 4, like that. 6, 2, like that. Okay. Okay, the next thing is, let's say that's part A. And part B looks a little bit complex. Let's make the px go to y dash because that's a new function. And let's say that's minus fx dash plus 4. And I move everything to the side. It's y dash subtract 4. And you negative that, and that equals to fx dash. So x won't change. X dash still equals to x. But minus y dash minus 4 will equals to y. So y dash will equals to minus y plus 4. Okay, let's still look at those points. First I have point 0, 0, I have point 1, 1, I have point 4, 2, and I have point 9, 3. Okay, that's the point like easy for me to work with at the beginning. So your x won't change. Your y will be negative y plus 4. Then 0, 0 will become 0, 4. Right, 0, 0 becomes 0, 4 because you sub y equals to 0 into this equation and you find out y dash. Okay, find out y dash. The next one will be 1, 1. You sub y equals to 1 into this equation to find minus 1 plus 4 is 3. So you have 1, 3. Okay, we find 1, 3. Okay, 4, 2. Sub 2 in, minus 2 plus 4 is 2. So you still have 4, 2 here. 9, 3. Sub 3 in, you have 1. So you have 9 and 1, which is here. So now you can complete this graph by connecting those points. But do not stop at the point 9, 3, 9, 1 because the graph can keep going into that direction. But you need to label the endpoints, which is 0, 4. And there's a point of inflection, point of intersection, which is 4, 2. Label 2 points is enough. You can label any 2 points. One endpoints and any points you like later. Okay, this one just gives you some idea of how we can sketch by using transformations. Now I will show you this one. Okay, this one is a little bit complex. So what I will do is find some points. Okay, find some points. So what points I have? Can you see 0, 1, Can see the point 1, 2 and the point 2, 4 and the point 3, 8. Is that 8? 3, 8. And the point 4 and 16. Okay, what function is that? What function is that? What kind of graph? Quadratic, linear, polynomials, square root, cube root, square, exponential, logarithm. Which one is that? What's that? Can you realize? Can you see that? Okay, 0, 1, 1, 2, 2, 4, 3, 8 is all 2 to the power of the x value. It's an exponential graph. Can you see that? 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. When you see all these coordinates, you should be able to tell what kind of graph is that. Okay, that's an exponential graph. And the shape tells you is either a parabola or exponential. Okay? So now we have those points. Okay, we have those points. Let's have a look at what we can do to find this, all of that. So let's do example A. So for A, y dash equals to 2fx dash. So y dash over 2 equals to fx dash. So y will equals to f dash over 2. So y dash equals to 2y. And x dash is still equals to x. So we can find a new set of points. Okay, we can find a new set of points. Let's say that's A, that's B, that's C. So we have x remain the same x. Y value will be times by 2. Okay, that's the points I can find. X remain the same, but y value times by 2. So 0, 2, 1, 4, 2, 8, 3, 16, but 4, 32 is too high, so okay, it's like that. Okay, and that's still endpoints. 0, 2, 1, 4. Just label 2 is enough. Okay, that's part B. Part A, question A. Let's have a look at what happened to part B. B got y dash equals to f2x dash. So y dash equals to y, 2x dash equals to x. So x dash equals to a half x. Y value remain the same, but x value has been halved. So that half is still 0, 1. That's a half comma 2. That's 1 comma 4. Half that is 3 over 2 and still 8. And half that is 2, 16. So we have 0, 1, a half and 2, 1 and 4. Okay, a half and 2, 2 is not good. A half and 2, 1 and 4. Okay, 1.5 to 8, 2 to 16. Okay, the shape looks like this. Okay, that's the shape of the graph. That's the green one, which is my part B. Okay, for part C, we will have y dash minus 6 over 4 equals to f bracket 2x dash minus 1. So y equals to y dash minus 6 over 4, then y dash equals to 4y plus 6. X equals to 2x dash minus 1. X dash equals to a half bracket x plus 1. Okay, x dash a half x plus 1. So the new x is x plus 1 and then half that. So that gives you a half. And that gives you 1 plus 1 is 2, 2 and a half is 1, 2 plus 3, 3 over 2, 3 plus 1 is 4, 4 and a half is 2, 4 plus 1 is 5, 5 over 2. That's all the x coordinates. And for the y value, it's 4y plus 6. Okay, it's 4y plus 6. So the first one is 1. So 4 is 10. The next one is 2, 8. 8 plus 6 is 14. Next one is 4. 4 times 4 is 16. 16 plus 6 is 22. 8, 32. 32 plus 6 is 38. 16, 64, 50. No. 4. 64. 70. Okay, it's too big in the end. What I can draw is the first 3. Okay, very likely I can draw the first 3. So I have a half and 10. 1 and 14, 3 over 2 and 22 is somewhere above here. Okay, be aware of where's the starting point. The starting point is here, a half comma 10. Okay, that's your starting point. And then you have 1 and 14 to label. Okay, because I'm not giving you the graph and you need to use some way to show this transformation. Okay, you need to use some way to show this transformation. So this table will be helpful. Okay, so what's the new x and new y compared to the old x and old y? So that's the method we use here. Okay, let's have a look at the example 3. Okay, now you have example 3 here. And let the domain is 0 to 6. Okay, the domain is 0 to 6. So here is 0, here is 6. Here is the midpoint, which is 3. Okay, so 3 and 6. Okay, so I haven't really tell you what is the formula. I just say that's a sine pi x over 3 plus c, where a and c are both positive and a is greater than c. Okay, A is greater than C, and the graph y equals to Rx is shown below here. Okay, so first of all, I want to find out all the special points. Okay, I don't really know. Okay, this is a pretty good question. Have a think about this with me because I don't know the value for A and C. So what's this line? This line must be y equals to C. What's this line? This line must be A plus C. And this line must be minus A plus C. Okay? And I will know the coordinates for this point must be 3 over 2 comma A plus C. The coordinates for this point must be 0 comma C. This must be 3 comma C. This point must be 9 over 2, which is 4.5, comma minus A plus C. And this last point must be 0 comma C, 6 comma C. Okay, that's my key points. If I can find those key points, I should be able to find the rest of like the shape of the graph. Okay, now it's telling you the graph of R undergoes the following transformation. Okay, there's a series of transformation happen. A dilation by a factor of 2 from the y-x-axis is changing the x value. The new x will equals to 2x, 2 original x. A reflection in the x-axis is changing the y value. Okay, it's changing the y value. So y dash equals to minus y. So that gives me my x dash will be 2x and my y dash will become negative y. Okay. Now the interesting point is here. How many points we have? 1, 2, 3, 4, 5. We have 5 points here. Your new x. Your new x equals to 2 old x. Your y equals to negative of that y. And let's put the 5 points down here. So the first one is 0 comma c. The second one is 3 over 2 comma a plus c. The next one is 3 comma c. And have 6 comma c. And I have 9 over 2 comma minus a plus c. Okay, so the x coordinates will times 2. That's 0, 3, 6, 9, and 12. The y value will be minus c, minus a, minus c, minus c, a, minus c, and minus c. Okay, let's have a look where is it. Let's have a look at where is 0 minus c. So 0 is here. minus C will be like the same distance from the top will be here. The next one is 3 minus A minus C. So 1, 2, 3, 4, 5, 6. Which the point will be here. And now 6 minus C. So 6 is here, minus C is here. And 9A minus C. Okay, 9A minus C. Where's 9? Okay, so 9A minus C. So it's negative of that, so which is here. The last one is 12 minus C, which should be here. Okay, the shape of the graph will look like this. That should be the shape of the graph, and you need to label the coordinates here. Okay, so that's the shape of the graph. So the x coordinates will be large twice, and the y value will be reflected by the x-axis. So the black graph will be the final graph. Okay, everyone, what we'll do tomorrow? Okay, I don't have class. We don't have class tomorrow, right? Okay, I'll finish up this on Wednesday. Okay, I will finish up this on Wednesday. And do you know, like, I have upload a practice sheet for you. Like, there are about 10 or 20 questions on that. It's all transformation questions. I want you to do that as an assignment. Like, I give you Thursday the whole lesson, you just work on those questions, okay? Not necessarily to complete all of that, but I want you to form 4 or 3 of you form a group to do questions together and check answers together. Okay, that's what I want you to do on Thursday lesson. So Wednesday, tomorrow, I'll finish up this. Yeah, those ones.